What's up, guys? In this video, I'm just going to talk about some of the main areas of math you would need to know if you wanted to understand the inner workings of ChatGPT. So let's get right into it. So really there are three main areas, and they're going to be probability, calculus, and linear algebra. So now let me talk a bit about how each one kind of fits into the ChatGPT picture so you can have a bit of an understanding of that. All right, so let's jump into it. So the first thing is probability, and this kind of sets the scene for ChatGPT and maybe natural language processing as a whole. So really, under the hood, one of the main things going on behind ChatGPT is a fancy autocomplete. Now, an autocomplete might take in an input of, say, a part of a sentence and try to predict the most likely next word in the sentence. For instance, you might have the sentence, "My cat is," and the autocomplete might try to predict what the most likely next word is. Now, really, there's many different choices for this word, so you have to have a framework to precisely formulate what the next word might be. In other words, it's a random thing, like there could be many different choices, and you have to assign a different probability to each word. So that at the basic level is kind of why probability might play a role in these fancy natural language processing models, and why it might be useful to understand it a bit. Of course, this is just kind of a basic example, and ChatGPT is using a bit more nuanced probability, but that gives you an idea of why it might be a useful thing to understand. Now, while probability is just really setting the scene for what you need to do with ChatGPT, linear algebra is helping you implement a lot of the details. Now, while probability helps us set the scene and give us a framework for how to develop these natural language processing models, really linear algebra in the framework of ChatGPT is helping you to implement the exact details. So really under the hood, to implement this ChatGPT, there are a ton of functions going on. And a function, remember, is just something that takes in an input and gives you an output. Now, it turns out that linear algebra provides an excellent framework for really describing and implementing very quote-unquote simple functions. Now, they're not simple if you've never taken a course in linear algebra, but for people that have a lot of experience with math, linear algebra actually gives us a framework for developing the perhaps most simple functions you could. So really, linear algebra gives us a framework for studying a bunch of simple functions. Now, how does this help with ChatGPT? Well, really what's going on is under the hood, ChatGPT is really just a bunch of these simple functions intertwined and combined in various ways to really create something special. Now, I'll be clear, I'm oversimplifying things quite a bit, but in reality, that is what's going on. Linear algebra has given us a framework to develop and understand a bunch of simple functions that we can program and implement so that we can combine them in complicated ways to produce crazy effective models. So that's what's going on. So the last area of math I talked about was calculus. So let's talk about how this really plays a role in the development of ChatGPT. So the way it works is, the way ChatGPT is designed is it starts out as being a terrible model, where it's just outputting gibberish, and slowly over time it works its way to becoming a more useful and effective model. And the way it actually makes these incremental improvements is through calculus. So the way it works is that these models are composed of, say, 100 billion parameters, and calculus is used to efficiently decide how to change the parameters over time to improve the model. The way this is done is that really calculus is actually made for this, and that there's something called a gradient, which tells us how to improve these parameters over time in the best way. So putting this all together, what's really going on is that probability tells us what should the goal of the model be. Linear algebra implements complicated functions so that we can achieve this goal, and calculus tells our models how to learn. All right, well, that's it for this one, and I'll see you in the next one.